Dear students, today we are going to discuss complex numbers. Before I proceed, please do let me know that you are able to hear my voice very clearly and able to view the screen properly. Can
Yes.
someone confirm? Yeah, okay, great. So, the first point what I would like to mention is that we know the square of every real number is always positive, correct? You take any real number, you make a square of it, you will always get positive. Okay. Then, if this is the case, then what is going to happen if we get a equation something like this? X square equal to minus 1. We know square of every real number is positive, correct? Then x square equal to minus 1 doesn't belong to a real number because x cannot be a real number, looks like. We just discussed that square of every real number is positive. If this is the case, then it is very difficult to find a x so that x square is equal to minus 1 or x square equal to minus 5 or x square equal to minus 3 by 7, whatever it is. So we are going to discuss on this topic that what is this then? Actually x square minus 1 leads to what? Leads to x square plus 1 equal to 0. And if you recall, dear students, from your previous knowledge, that this is a polynomial equation. And what you know? That a polynomial equation of degree n has at most n roots. We learned this thing, na?
Yeah.
So definitely x square plus 1 is a polynomial equation of degree 2. X square plus 1 equal to 0 is a polynomial equation of degree 2.
Yes.
So it must have two zeros. It must have, means the polynomial has two zeros. That means that corresponding polynomial equation has two roots. What are those two roots? How to find them? And what are those roots at all? That we are going to discuss. So dear students, what we just learned is that the square of every real number is always positive. That is also, by the way, it is not a learning that we are just, you know, discussing it. That the square of every real number is always positive. Then the solution to the following equation, that is x square plus 1 equal to 0, that implies x square equal to minus 1, cannot have any real value of x, cannot have any real value for x. This equation, x square plus 1 equal to 0, cannot have any real value. Then what are those values? Okay. So there is a fundamental demand, okay, that we should discuss on this. So there is a need to define different systems so that we can define the solution to the equation like x square equal to minus 1. Correct or not? So far, if you remember, so far in the number system, we have knowledge on the real number system, which we understood from a set theoric notation is the superset of all kind of number system we have learned so far. What are the number system we have learned so far? Natural number, whole number, integers, okay, rational numbers, irrational numbers, all are actually the subset of the set of real numbers. That means real numbers actually carry all these numbers. Now with this knowledge, here we find, okay, with this knowledge, here we find one equation, that is x square equal to minus 1, where the solution is not a real number. So then the last point, hence I wrote that last point, that so there is a need to define different number system so that we can define the solution to the equation x square equal to -1. Okay. In general, if you recall, the quadratic equation, okay, what you have learned in the earlier classes, in your previous year, I hope, in your class 10, that in general we need to find the solution to the quadratic equation ax square plus bx plus c equal to 0, where the discriminant b square minus 4ac is less than 0. Correct? So these are the points. What I say, dear students, is actually the justification that why we should learn or why we should define a new number system. And for that, we define a new symbol. And that symbol is that, I. And what that symbol represents? That I represents, it is a square root of -1. Okay? So let us introduce a new symbol I, so that I is equal to square root of -1, and we will get I square equal to -1. I square equal to -1 means what? I square plus 1 equal to 0. So our equation, what we are discussing, dear students, is that x square equal to -1. Correct, na? That solution we are trying to find, and here we are getting that I square equal to -1. So as if x is equal to I, na? If you make a correspondence 1 to 1. That means I is a solution to the equation x square plus 1 equal to 0. Correct or not? All of you agree to me, I hope? That if x square equal to -1 is the equation, and as we introduced a new symbol called I, where I is equal to square root of -1, then we will get I square equal to -1, that is I square plus 1 equal to 0. Means I is a solution to the equation x square plus 1 equal to 0. That is quite obvious. Now we can also write this thing in little different form also. In which way we can write this thing? Is that the moment we write x square equal to x square plus 1 equal to 0, that implies, so x square plus 1 equal to 0. From that, we can write that x square plus, x square minus I square equal to 0. Because I square is equal to what? I square equal to -1, na? So minus of I square should be +1, correct? So if I write one more step, I can write I square plus x square plus 1 equal to 0. I can write x square minus of -1 equal to 0. This implies what? This implies x square minus, what is -1? -1 is I square. X square minus I square equal to 0. This implies x plus I into x minus I equal to 0. So this implies what? This implies x is equal to I and minus I. Or we can write is that x is equal to square root of -1 or minus root of square root of -1. These are the two solutions. Few minutes back, we recapped one statement. What we learned previous year is that a polynomial equation of degree n has at most n roots. Here we a polynomial equation of degree 2, so it should have at most 2 roots. What are those 2 roots? One root is I, which is equal to square root of -1, and another root is minus I, which is square root of minus of square root of -1. Dear students, so what we introduced so far? We introduced so far a new symbol Whatever we have discussed in the last several minutes is that just to justify that why it is required to introduce a new symbol I, why it is required to for a new number system, a different number system rather than the real number system to solve equation like x square plus 1 equal to 0. Correct? And hence we come to a point that is called a complex number. So what is complex number? Complex number is in the form of a plus ib. Okay. So what defines a complex number? That you need to understand very well. Is that a complex number, you know, is in the form of a plus ib. A number in the form of a plus ib, where a and b both belongs to the set of real numbers, and I is equal to square root of minus 1, is called a complex number. For example, if I say that a number called 5 plus 7i, it is a complex number. Why? Because I am able to express it in the form of a plus ib, which is 5 plus 7i, where both a and b, that is 5 and 7, belongs to the set of real numbers. I can express a number called 1 plus 0 into I, that is also a complex number, where 1 and 0 both are real numbers, belongs to the set of real numbers, and I is square root of minus 1. But what is 1 plus 0 into I? 1 plus 0 into I is nothing but 1, correct, na, dear students? And what is 1? 1 is a real number, we know. But I can express that in the form of a complex number where the imaginary part, I'll discuss in details about the imaginary part, where imaginary part is 0. I can write a number something like that, 0 plus 7 into I, where both 0 and 7 are belongs to the set of real numbers. I can write something like this, minus pi plus 11 into I, where both minus pi and 11 belongs to the set of real numbers. So all these numbers, dear students, what you see, these are all complex numbers. Why it is a complex number? Because it satisfies the definition of a complex number. Let's recap. What is the definition of a complex number? A number in the form of a plus ib, where ab belongs to R, the set of real numbers, and I is equal to square root of minus 1, is called a complex number. So we are able to express this as a complex number. Clear, dear students? Now, the point is that in the complex number a plus ib, a is known as the real part. Let me first put that note in front of you, then let me explain. This is very important, dear students. Is that in the complex number a plus ib, a is known as a real part, b is known as the imaginary part. That means in the number 5 plus 7i, if we write a number called 5 plus 7i, then 5 is known as a real part. This 5 is known as the real part. This 5. And this 7 is known as the imaginary part. It is known as the imaginary part. If b is equal to 0, right? If b is equal to 0, the complex number is known as a purely real number, which I said in case of 1 plus 0 into I. If you see 1 plus 0 into I, where the b is 0, correct or not? It is something like that, 1 plus 0 into I. And that is actually what? Where b is equal, it is in the form of a plus ib, where b is equal to 0. And this representation is known as a purely real number. And that's what we know. 1 plus 0 into I is what? 1. That is a purely real number. Correct, no? And If a is equal to 0, the complex number is known as purely imaginary number. That means what? One example, we have seen this thing also. If you look into this thing, 0 plus 7 into I. So 0 plus 7 into I. In this, we see that a is equal to 0. And we define this number as a purely imaginary number because the real part is nowhere, real part is 0. So in a complex number like a plus ib, there is a real part and there is an imaginary part. The part which is before the plus sign is called a real part. That is a. And a number which is attached with I, that is multiplied with I, that term is known as the imaginary part. Now, in this context, I hope you could ask this question that, sir, in that a plus ib, what is this plus stands for? Is it really an addition? Right? It is a very obvious question if you have in your mind. Generally, what you know, 5 plus 7, if I write, what do you imagine? It is 12. If I write 5 plus 7, what do you see? That is a 12. That is the way the plus is used to do. Then what about a plus ib? What is that, plus represent here? Is plus represent a, summation? If it is, then how it is a summation? So, dear students, here I would like to mention a very important point, very conceptual point you should be knowing. Please note that a plus ib is a formal expression to represent complex numbers, in which ab belongs to R and I is equal to square root of minus 1. The set of all complex numbers is denoted by C. That is the letters capital C. The way we see that, the set of natural numbers represented by capital N, set of real numbers is represented by capital R. So, set of complex number is represented by capital C. So, in a set theoretic notation, how you can write C? C is equal to X, such that X equal to A plus IB, in which both A and B belongs to the set of real numbers. In this way, we can represent capital C represent the set of all complex numbers. The thing is that what I said, A plus IB is a formal expression to represent complex number. A plus IB, what I write is that A plus IB represent A plus IB, I can write very clearly, A plus IB is a formal expression, to represent complex number. To represent complex numbers. Now, I want to emphasize on this word called formal. Okay, what is meant by that? The term formal indicates that we do not attribute any meaning to them. We do not ask what they might signify, and we do not try to relate any such expression to any real thing. We regard them in a strictly formal fashion. To obtain such an expression, we have to take two real numbers a and b, and using the auxiliary symbol plus and I, construct the expression like a plus ib. For instance, if we take this one called 4 plus 5i, 7 minus 9i, 2 plus 0i, 4 plus 0i, pi plus 11i are all complex numbers. Likewise, we say nothing about the meaning of these auxiliary symbols plus and I. Okay, when we say a complex number called 4 plus 5i, okay, from here what we want to mean? We want to mean is that This plus sign here is not the sign of addition that we used to do. We regard this as a formal symbol, plus sign as a formal symbol. The whole purpose here is to help in the construction of the formal expression which we desire to have, that is a plus ib. Okay, so here plus and I, these are the auxiliary symbols, it's symbols. Okay, because what I wanted to mean by that it means is that a plus ib, that doesn't mean that you are actually adding a and ib. You really cannot add in that sense. Okay, so it is a symbolic representation. Now, so this whatever I just said, I want to keep it here for your information. Okay, so what I'll suggest you can go through this statement uh, in next 2 minutes. Okay,
Yes.
got it, dear students. Okay, great. Now what we are going to do is that we are going to define few more things. That if we see that z is equal to a plus ib, you know what we see is that if z is equal to a plus ib, then the real part we know it is a, and imaginary part we know as is a b. The real part is denoted by rez. Okay, what I wanted to mean is something like this: that if z is equal to a plus ib, then a real part is denoted by rz or sometime rez like that, and imaginary part is represented by iz or sometime by imz. Rz, or you can write is that rez sometime you will see, or you can say im, just imaginary z. So if you see a complex number is given like that z, and after that there is the expression rez or rz, you can say that, oh, it is actually I need to take the real part from that complex number, which is a. So that means what? So if z is equal to a plus ib, z is equal to a plus ib, this implies a real part of z is nothing but a real number a, and imaginary part of z, that is also a real number, and that is a real number b. Correct, not dear students? Okay. Now, the next point what I'm going to discuss is that, as I said, the set of complex number is denoted by C, and we can define, in the set theoric notation, something like this. I did it today, but in previously I discussed this thing today. But in this way also you can represent it. The set of all complex numbers is denoted by capital C and is defined as capital C is equal to A plus IB, where A and B belongs to R, and I is, square root of -1. Now let us take two complex numbers. One is Z1 equal to A1 plus IB1, and Z2 equal to A2 plus IB2. Now, if we say that these two complex numbers are equal, that is Z1 is equal to Z2, that is possible if and only if, A1 is equal to A2 and B1 is equal to B2. What does it mean? It means is that if these two complex numbers z1 and z2 are equal, then a1 has to be equal to, means the real part of z1 has to be equal to the real part of z2, and imaginary part of z1 has to be equal to the imaginary part of z2. And the converse is also true. That means what? If we get two complex numbers z1 and z2 such that the real part of z1 is equal to the real part of z2 and imaginary part of z1 is equal to the imaginary part of z2, then you can conclude, oh, these two complex numbers are equal. Z1 is equal to z2. Means that is why this statement, if and only if. That means z1 is equal to z2 if a1 equal to a2 and b1 equal to b2. And the converse, that is, if a1 equal to a2 and b1 equal to b2, then you can say z1 is equal to z2. Correct, not dear students? Now, what we are going to do is to find the square root of a complex number. We are going to find the square root of a complex number, and that is the part of our discussion now, and how to find the square root of a complex number. So let me go to a new page and discuss this thing. Sometimes questions come from this particular topic to find the square root of a complex number. Okay, and we should be knowing that how to perform that. So we need to find the square root of a complex number. Suppose let's take a complex number a plus ib, and we are going to find the square root of this complex number a plus ib. Then what we are going to do? Then what I'm going to do is that that we need to find that square root of a plus ib. Square root of a plus ib. And to find the square root of a plus ib, what I can write is that is equal to x plus iy. That is equal to x plus iy. Square root of a plus ib is equal to x plus iy. From here, what we can write? From here we can write is that a plus ib is equal to x plus iy whole square, correct or not? This implies a plus ib is equal to x plus iy whole square. And that means what? That means we can write that a plus ib is equal to a plus ib is equal to x square plus I into y whole square. Let me write, because as we have started learning this thing, I into y whole square plus 2 into x into iy. This implies a plus ib is equal to x square plus I square y square. I square is equal to minus 1, dear students. So x square minus y square plus I into 2xy. So what we see is that a plus ib is equal to x square minus y square plus I into 2xy. Now, dear students, we just learned few minutes back that two complex numbers are equal if their real part are equal and imaginary part also equal. So a plus ib is equal to x square minus y square plus I into 2xy. That means that a has to be equal to x square minus y square, correct or not? This implies a is equal to x square minus y square. And what we can write is that b is equal to, we can write like this, x square minus y square, and b is equal to 2xy. Let us give this as equation 1, and this is we give equation 2. Now what we are going to do, dear students, is that we are going to make x square plus y square whole square. Okay, let's find. if we do x square plus y square whole square, what we are going to get? So if we make x square plus y square whole square, that is equal to x square minus y square whole square. That is, if you recall, a plus b whole square is equal to a minus b whole square plus 4ab. So plus 4 into x square into y square. Correct or not? Now what is x square minus y square? That is equal to a. So x square minus y square whole square equal to a square. And what is 4x square y square? That is equal to 2xy whole square, and 2xy equal to b. So it is b square. So from here what you can write is that x square plus y square whole square is equal to, as if it is a square plus b square. Correct, not, dear students? And from here what we can get? From here we get that x square plus y square, if you take a square root, x square plus y square is equal to square root of a square plus b square. Correct? So now let us give this as equation number 3. Now you may think, sir, why you are not taking x square plus y square is equal to minus of square root of ab? Generally, what we see that x square plus y square whole square is equal to ab means what? This implies that x square plus y square is equal to plus minus square root of a square plus b square. But you see, can the squares of two positive numbers be negative? Not. Here x and y are real number, but x square is a positive real number and y square is a positive real number. So x square plus y square is a positive real number. That positive real number cannot be negative. Hence we eradicate the negative value and we only consider that x square plus y square equal to square root of a square plus b square, and we give this as an equation 3. Now let us focus on equation 1 and equation 3. Let us focus on equation 1, which is x square minus y square equal to a, and equation 3, that is x square plus y square equal to root over of a square plus b square. Now if we add both sides of the equation 1 and equation 3, so I can do it here. If we add both sides of the equation 1 and equation 3, what we are going to get? We are going to get, x square plus 2x square is equal to 2x square is equal to square root of a square plus b square, square root of a square plus b square plus a. So this implies x square equal to square root of a square plus b square plus a by 2. That implies x is equal to plus minus complete square root, dear students, complete square root of a square plus b square plus a divided by 2. In the similar manner, we can find the value of, the value of y's. How we can find the value of y? If we subtract, both sides of the equation 1 from the equation 2, then what we are going to get? So it is like that 3 minus 1, and after rearrangement means we can bring, x square y square, one side. Then what we are going to get in the similar manner, you are going to get y is equal to plus minus square root of, in the same fashion, same manner, the way I did in the previous one, you will get square root of a square plus b square minus a divided by 2. Now, so we get two values of x, plus minus as you see, and two values of y. Now, let us concentrate on the equation 2. Equation 2 tells that b is equal to 2xy. So, if b is positive, then what we can conclude? Either xy are of the same sign, right? Not either. It is the only possible that x and y has to be the same sign. That means both x and y are positive or both x and y are negative. And if b is negative, then x and y has to be in the opposite sign. So from equation 2, what we can conclude is that from here, this implies if b is positive, if b is positive, this implying x and y have the same sign. X and y have the same sign. And if b is negative, then what we can conclude? We can conclude is that x and y have opposite sign. Correct? So what we can observe? We can observe that, square root of a plus ib denotes two complex numbers, correct? Except b equal to 0, correct, no? So two note here I would like to give is that the first point, I can use a different color here. The first point what I going to mention is that square root of a plus ib denotes two complex numbers. Square root of a plus ib, as we see, because x plus iy, as we found two values, a square root of a plus ib is equal to x plus iy. Then we found that two sets of values of x and y. Okay, so if b is positive, then there are x and y has to be the same sign, means both positive, both negative. And if b is negative, then x and y has to be the opposite sign. That means if x is positive, y is negative, and if x is negative, y is positive. That means always, we get two, complex numbers. X square root of a plus ib denotes two complex number except when b equal to 0. The square root of a plus ib denotes two complex numbers except when b equal to 0. Except when b is equal to 0. And in that case, square root of a denotes the one complex number, correct or not? Square root of a, because there is no b there. Okay, in that case, square root of a denotes the one complex number. Denotes the one complex number. Let's take an example. One example is that square root of if you do 8 plus 6i, and if you apply this formula of whatever we learned about x and y, x and y, if you do this thing, then you will find it out, it is landing up with plus minus 3 plus I. Okay. But if we find that square root of, square root of 4, okay, if we make that square root of 4, what we get? Square root of 4, if we make, that we are going to get is that 2. Correct or not? That means when b is equal to 0, square root of a, when square root of 4 means what? Square root of a plus ib, where b is equal to 0. And we just learned that if b equal to 0, then square root of a plus ib, that is square root of a, denote only one complex number, that is 2 in this case of square root of 4. And if you make square root of minus 4, that is also in the form of square root of a, that is equal to what? That is equal to 2 into I, one complex number. So what
But in the first case, how do you say 2 as complex number?
Because 2 is a complex number, 2 plus 0 into I. 2 is the real part and 0 is the imaginary part. It is a purely a real number. If you recall what you learned, that a complex number is in the form of a plus ib. Let me go to the previous one. Thanks for asking this question. You see, a complex number is in the form of a plus ib, where a is known as the real part. Okay, if you recall this thing, the number 1 also we represented in the form of 1 plus 0 into I. If b is equal to 0, then it is this complex number is known as a purely a real number. Correct? And what we did here?
Yes,
We got 2. 2 is nothing but 2 plus 0i. 2 plus 0i is a complex number, but more specifically we can say it is a complex number whose imaginary part is 0. Correct? No? Clear or not clear?
So why don't we take like plus minus 2 there, like root 4?
I'm sorry, come again.
So why can't we take like plus minus 2 like for root 4? I didn't understand that.
Now, what I'm telling is that, let me give you the background. What I'm saying, what you observe here, we observe that the square root of a plus ib, we get x is equal to plus minus, this is the value of x, right? In the square root of a plus ib. If we assume that square root of a plus ib is equal to x plus iy, then these are the value sets of x and y we get. Now the point is that a plus ib, x has 2 values, correct or not? And y has 2 values from here. Now, what are the values we are going to take that is driven by the b? And what we observed here, if b is positive, then we can take x and y has to be of the same sign. That means if x is positive, we should take y is also positive. And if x is negative, we should take y is also negative. But if b is negative, then x and y has to be of opposite sign. That means what? If we take x positive, y negative, or if we take x negative, y positive. So that means what? Square root of a plus ib denotes 2 complex number except when b is equal to 0. If b is equal to 0, then square root of a plus ib reduces to square root of a.
Yeah.
And in that case, square root of denote only one complex number, or I can say precisely correctly, exactly one complex number. How? Square root of 4. Square root of 4 is what? 2. Correct or not?
Yeah.
What is square root of minus 4? Is 2i. Why is I? I is equal to square root of minus 1, na?
Okay.
So that is why that is only one complex number. But what Sagnik you asked, that how come 2 is a complex number? 2 is a complex number by definition. Because we can express 2 is equal to 2 plus 0 into I. where 2 is in the form of A, 2 is kind of A and B is kind of 0. So you are able to. But if you look into the another example,
Root 4 you get -2 as well, so you can just write -2 and not 2. Why?
correct. That is the point. So now thing is that here what you are getting, that square root of 4, if we write -2, correct? Now that's what you are telling. Now square root of 4, if you write -2, then what you are going to get? That 4 is equal to -2 whole square. Correct, na? But that is defined by the other thing, na? That A and B. So what I'm saying is that that when you take that square root of 4, square root of 4 is equal to 2. Your question is that why square root of 4 is -2? That's why your question, no? Now the thing is that, think about that square root of 4 we are expressing in terms of, let's apply in this one. Okay, if you write x and y, so here what we are going to get, b is equal to 0. In this particular case, b is equal to 0. Now apply in this formula. What you are going to get? You are going to get x is equal to plus minus square root of a square plus b is 0 plus a by 2. Okay. Now the point is that if we take square root of 4 as -2 as well, then what will happen? That we can write 4 is equal to -2 whole square. Correct, na? 4 is equal to -2 whole square. Now in that case, what is going to happen is that we can we can write that square root of -4 is equal to, let's write it down, square root of -4. Your point is that how we can find the value of square root of -4. Actually, that I wanted to bring into the second part. Let me discuss the second part, then it will be amply clear. Okay. Let me discuss the second part, then it will be amply clear. You will be completely understanding what I am going to tell about the square root of -4. Now the second part is that the product square root of a into square root of -1, the product, let me write explicitly, the product square root of a into square root of -1, okay, is equivalent to the quantity, is equivalent to the quantity what is equivalent to the quantity of square root of -a, except when a is negative real number, except when a is a negative real number. A is a negative real number. Now let us deep dive into it, as you asked, that square root of -4. So square root of -4 into square root of -1, what we are going to get? What is the square root of -4? That we understood is equal to 2i, na, dear students? I hope there is no confusion here. Square root of -4 is equal to 2i. And what is that square root of -1? That is equal to I. Correct or not? So this is equal to what? This is equal to 2 into I square. Okay. So this is equal to 2 into I square. That is equal to -2, while square root of -4 minus 1, square root of -4 into -1 is equal to square root of 4 is equal to 2. So what we conclude? square root of a into square root of b, square root of a into square root of b, that is equal to square root of a into b, only if at least one of a or b is non-negative. Only if at least one of a and b is non-negative. Let us understand. So what we understood, that square root of minus 4 into square root of minus 1. Let's look into it here. Let me use a different color. Square root of minus 4 into square root of minus 1 is equal to what? Square root of minus 4 is 2i, and square root of minus 1 is equal to I. So we get 2i square, that is equal to minus 2. Correct? While we know what? Square root of minus 4 into minus 1 is equal to square root of 4 is equal to 2. So is it that these are mutually conflicting statement? Dear students, what we see, square root of minus 4 into square root of minus 1 is equal to minus 2. But exactly square root of minus 4 into minus 1 is equal to square root of 4, that is equal to 2. So we conclude square root of a into square root of b is equal to square root of ab only if at least one of a and b is non-negative. Correct now? So, for example, here you see square root of 4 into square root of minus 1. That should be equal to square root of minus 4 into minus 1. Only if at least one of the a is non-negative. But which is not the case now? In case of square root of 4. Square root of 4, what we see?
You get different values for them.
Exactly. So that is from the definition. Is it clear, dear Sagnik?
Yes, sir.
Okay. So now, what we can do is that we can solve one problem together. I'll take another 5 to 10 minutes, dear students, so that if we solve one problem, it will be good that exactly we know how to find the square root of a complex number. So let's find let's find square root of you can also open your notebook and you can do it with me. Let us find the square root of 8 minus 59. Okay, now if you recall this formula, the square root of 8 minus 59, what we know, x is equal to plus minus square root of a square plus b square plus a by 2, correct or not? So let us write it this. If we assume, sorry, that 8 plus, let me use a different color. Let me use this color. So let us assume that 8 minus 59, dear students, very minutely look into it. That we are going to write is that equal to a plus ib. That implies what? That implies a is equal to 8, na? And b is equal to minus 15. Now at the same time, if we write square root of a plus ib is equal to x plus y, then we know what is the value of x. We know the value of x is equal to plus minus a big square root. Inside that square root, there is a numerator which is equal to square root of a square plus b square plus a divided by 2. Please note that the 2 which is in the denominator, which is also under square root. And if you find this one, we'll find something like plus minus square root of 5 by 2. I'm not spending time to evaluate a square plus b square when a is equal to 5 and b is equal to minus 15. You can do it, you'll get it. And what is the value of y? We know, dear students, y is equal to plus minus from the formula square root of a square plus b square minus a by 2. That is equal to plus minus 3 by root 2. I'm so sorry, I made a small mistake. Did you find that mistake? Here it should not be plus minus square root of 5 by 2. It should be square 5 by plus minus 5 by square root of 2. Got it, no? So now, what are the values of x we got? So values of x, very important lessons, dear students. So values of x we are getting is that one is 5 by root 2 and another one is that minus 5 by root 2. What are the values of y we get? One we get is that 3 by root 2 and the other one is that minus 3 by root 2. Now, which one to take? That is driven by whether b is positive or negative. You see, dear students, b is minus 15, which is negative. So xy have opposite sign, correct or not? As b is negative, xy must have opposite sign. So now if we apply that opposite sign, if you take x is equal to 5 by root 2, then y has to be minus 3 by root 2. That means what? Square root of 8 minus 15i is having two values. If we take x positive, that is 5 by root 2, then y has to be minus 3 by root 2. Correct or not? Plus I into minus 3 by root 2. And if we take x negative, that is minus 5 by root 2, then what has to be y? Y has to be the positive value, that is I into 3 by root 2. 3 by root 2. Let me write properly. Now if we club together, okay, that 5 by root 2 plus I into minus 3 by root 2 and minus 5 by root 2 plus I into 3 by root 2, then what we can, if we club together, we will get square root of 8 minus 15i is equal to plus minus 1 by root 2, you can take common, you can write 5 minus 3i. Any doubt, please do let me know. Absolutely clear, dear student?
Yes.
Okay, so with this, I would like to conclude the class for today. There is no specific DPP you need to solve today because I need to cover a few more points that we'll be discussing tomorrow. But what I'll do, dear students, I'll give you some questions to find the square root of. Okay.
Yes.
Few questions I'll give to find the square root of, and that will get in the assignment. But before I conclude, dear Saknik, you raised a very valid point. You understood that why square root of 4 is equal to 2.
Yes, understood.
And not minus 2. Okay, thank you. And these are very fundamental questions. I appreciate. So thank you, dear students. As you do not have any further question, let me conclude the class here. And tomorrow we will have our class at 9 o'clock in the morning. Thank you very much.
Yes.